Today we're given a problem with a 32-bit number, and we want to return a new number with the 4th bit set to 0 and the 7th bit set to 1. Okay, so we need to break down this problem in steps. So first we want to create a mask. So we're kind of working on this this section first, and then we can do the 7th bit a little bit later. Okay, so mask, we're going to start with mask equals 1u, which equals 3, 4. So I'm going to copy this. So that's 4. So that's our first byte. So 1, 2, 3, 4. Okay, so here should be 32 bits, and 1u just is the number 1 unsigned, so it just creates a 1 bit in this least significant bit section, and I guess leaves the other bits to 0. Okay, so now we want to get to our 4th bit position. So this will be something in the code like this, and then we can just copy this just for demonstrational purposes. So this we need to shift over 4 positions, so this goes 1, 2, 3, 4. So the 1 will go here, and this gets filled with a 0, sorry. Okay, so now we've kind of targeted this 4th bit, but the problem with this question is we want to set this to 0, and a way to do this is using the tilde operator. So tilde operator, it flips all bits. Flips all bits. So here we'd have something like tilde equals, and then all of these, we're kind of at this section here. So everything you see that's a 0 becomes a 1, and then everything that you see is a 1 becomes a 0. So we end up getting a mask that now looks like this. So this is our current mask. Now we want to apply the mask to our number. So this will be num and mask. So let's just say we're given num equals so let's say num equals a number with all zeros, just as an example. If we AND this with our current mask, here we'll get num and mask equals, if we apply a 1 with a AND operator with a 0, this will leave the bits in their original position. They'll leave these unchanged because both numbers have to have a 1 when applied to the AND operator for a 1 to be returned. So 0 and 1 is going to equal 0. And then same with these next bits. But what happens here is we have 0, 0, 0, but we have 0 and 0, so that is still going to leave us a 0. So we have our original number returned, but this 4th bit is definitely guaranteed at 1, because if we use a different example, if this number is kind of all ones here. If we apply a mask to here, we're going to get 1 and, let's just get rid of this. 1 and 1 will still return 1 with the AND operator. And then when we get to 0 and 1 in this position, we're going to get a 0 here. So in both cases, with any binary number, that being 0 or 1, this fourth position is always going to have a 0 here. Cool, so let's actually write the code now. So unint 32t equals, new number equals the original number applied with a tilde operand for the 1 mask, which we created at the start, and then we shifted that over by 4. So yeah, number 1 shifted over 4 positions gets us here, and then we apply this tilde operand and it flips all the bits, and then we apply this mask with our original number. Okay, so now we just have to do this section of the code. Okay, so yeah, we want to do something similar where we want to create a mask and then we want to shift it over 7 positions. So I'm just going to copy this. So this is position 1, and then it's going to go 1, 2, 3, 4, 5, 6, 7. So the 1 will go here. Yeah, that looks right. Okay, so now if we apply an OR, it means that because our mask here has a 1 in this position, if we apply any number with this mask with an OR, it means that we're guaranteed to return a 1 in this position, because 1 in an OR operand is always going to return a 1. Both bits do not have to be a 1. So it's going to just change this 7th bit. So we can go new number OR equals, we can go num, I think we can just go, let's put this here first. Equals, I think this should be right. Let's try and run a test. New number OR equals new number OR equals 1u shifted by 7. New number equals num, and let's have a look what I've done here. Okay, I think we just need to return this new number now. Okay, looks like we passed our tests. Sorry, there should be a 7 here. Yeah, not a great explanation, but here it is. Here's the working code.